Okay, the other law that you need to be familiar with is called law of cosines. This law is going to be, or equation, is going to be used whenever you have the other patterns of congruence. So what other patterns of congruence do we have beside ASA and AAS? Do you guys remember? SSS and SAS. Okay, so those are the other two. The two that involve two sides are the ones that you can use law of cosines for. You do not ever have to memorize the law of cosines. Here's what the law of cosines will look like. It's going to say c squared is equal to a squared plus b squared minus 2 times ab times the cosine of c. Again, you're dealing with triangles that are non-right triangles. Side A is opposite angle A, side C, side B, opposite their respective angles. And you can think of this in 3 different forms, because if you're solving for A, then it would be a squared is equal to the sum of the squares of the other 2 sides minus twice the product of those sides times the cosine of the angle opposite this side that we began with on the left side of the equation. Which means the final form would be, if we want angle B or side B, b squared is equal to the sum of the squares of the other 2 sides minus twice the product of those 2 sides times the cosine of the angle opposite this side here, B. This is the form that I'm going to provide for you. I'm never going to write all of them down, but really all this means is one of these 2 pieces of information is your unknown. Whichever one is your unknown, the other one is the side or the angle opposite that unknown. And you'll see as I go through an example here of how this can be applied. So let's say I take a triangle that has sides of 5, 8, and 9. Is it possible to have a triangle with these sides? Does that fit triangle inequality? Yeah. Okay. So if we looked at this, and in this particular case, you could solve for any angle that you want to solve for. Okay, let's say I wanted you to solve for angle A. Okay, the pattern of information that you're given is SSS, so that means you're going to use the law of sines. And if A is your unknown, what does that mean we're going to start with? Which side will we start with? So whatever your unknown is, look opposite that. Okay, you're going to start with those 2 pieces of information, and those are going to be on the outer parts of your equation. So it's going to be the very first thing and the very last thing. So here our very first thing is going to be this number 8, because that's the side. So the equation that we'll use to solve this is 8 squared is equal to the sum of the squares of the other 2 sides minus twice the product of those other 2 sides, all times the cosine of our unknown, in this case A. All right, now here's a number of you have attempted some of these problems in your book. You cannot use the solve key to find the angle. The solve key on the TI isn't set up to find the inverse functions. And so it gives you like some symbolic notation for answers. It has like an @ symbol in it and doesn't make any sense. Okay, so I'm going to go through 2 different ways to go through and solve this. Okay, the first way is to kind of progressively work through this problem. Anytime you look to isolate your variable, you undo order of operations. So we're going to we could solve this by undoing the order of operations. So when you're looking at the order of operations, you usually go parentheses, grouping symbols, exponents, then you go to multiplying and dividing, and then you go to the adding and subtracting. Okay, so we're going to go in the reverse order. We're going to undo the adding and subtracting. So here's the first thing that we'll undo. So step 1 would be subtract this quantity. So here on the calculator, I'll do the process. So I start with the left side. I'm going to undo this quantity. So I'm going to subtract a 5 squared and subtract a 9 squared from both sides. I'm then going to hit enter. There's step 1 done. Now, if I cross this out, will everybody understand? Crossing it out means I've already applied it. So you just undo that. Then you can move on to step 2. Step 2, you have to undo this process. So to undo multiplying by cosine of A, we have to undo it and divide. So now in our running total here, we can take that whole quantity and divide by, and I'll put it all in parentheses. -2 times 5 times 9, close my parentheses. So I'm just undoing this group of operations. Hit enter, and I have my relationship that 7/15 is equal to the cosine of A. So now I have my cosine ratio. Once I have my cosine ratio, what would I have to do to actually solve for angle A? Yeah, take the inverse of that fraction. And so now if I take the inverse cosine of my fraction 7/15, so I'm just going to go highlight that. I want a decimal value, so I'm going to put a decimal inside. And when I hit enter, here's my angle measure. So my angle measure is about 62.2. Okay, so here's angle A. All right? All right. So let's take a look at the other way that you can use your calculator to solve this. Because some of you like using the solve key, I'm going to show you how you can do that. It just takes one slight tweak on your calculation. So let's say we want to find angle B next. Okay. Do we have to use law of cosines to find angle B? We could use this. Now we have two sides in a non-included angle, right? So we could actually use law of sines for this. Yeah, but it doesn't matter. You can use either one, law of sines or law of cosines. So let's look at the second way of using law of cosines to find angle B. Okay, so if angle B is our unknown, what side are we going to start with in our equation? Side opposite it, or so we get 9 squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides, all times the cosine of the angle that we're trying to solve for, B. If you want to use your calculator and the solve key on here, your calculator doesn't know how to handle the cosine of B. So what you can do is you can kind of let this be x, or any unknown. So substitute in an x for that, and you can now use the solve function. So if we type in solve, and we say 9 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times x. I'm letting x be the entire quantity cosine of B. Okay. And if I want to solve for x, so parentheses x, and then close my solve function down, when I hit enter now, okay, first of all, I do want this to be in a decimal form, so I'm going to hit the green diamond key. When I hit enter, this now gives me my ratio for the cosine of B. So I can now say that 0.1 is equal to, and now I can substitute back in for x. I found x, but x was cosine of B, so 0.1 is my cosine ratio for angle B, and so now what would I have to do to find B? The inverse cosine of that value. And so then you can, again, simply solve inverse cosine. And now, if this is an exact answer, you may want to highlight it and then delete the x equals part. In this particular case, you could just type in 0.1, but you want to use the exact answer. Hit enter, and I get my next angle. So angle B is 84.3 approximately. And then finally, for angle C, what would I do to solve? Easy way to do it is 180 minus 84.26. Again, I'm using my exact answers, right? Minus, go up to 62.2, hit enter, and I get 33.6 approximately. Okay, what's going to happen if I type in or enter 33.6 right here, though? It's not consistent, right? So if this is the case, just because you had to kind of reconcile the measures, go ahead and put a 0.5 here. When you guys enter these online, I'll give some leeway in the answer. So I'll usually give it about 1/10 of a discrepancy of 1/10 in any answer for this, because it's possible, if I'm asking you to round it to the nearest tenth, that it doesn't fit. So you can make it fit. Make sure it's consistent with what you would expect. Now, if we looked at these, do the angles and side lengths do they measure up to what you would expect based on comparisons? Largest side, 9 opposite the largest angle. Smallest side, 5 opposite the smallest angle. So it's consistent with what you would expect. Okay, so that's law of cosines using the SAS form.